Alright, Trig, day number 3, some compound identity stuff. In a different video, I'm covering the proof of what we call CoCo-CC. Alright, here's the formula for CoCo-CC. Cosine A minus B equals cosine A cosine B plus sine A times sine B. Okay, I'll cover that in a different video, but that's one of our identities for today. Let's move on. So as I just said there, cosine x minus y would be cosine x cosine y plus sine x sine y. This is an even identity, right? Even odd identities. This right here, cosine, is an even function because it's symmetrical about the y-axis. Therefore, cosine of negative x is actually equal to the same output as cosine x. Okay, moving on, the second one here is going to be very similar to what we had proven in this other video. Except the only difference is now that there's a plus here between these two angles, we'll swap that for a negative in between those two terms. So here we would have cosine of x cosine of y minus sine x sine y. Cool. Double angle identity, we could really write this if we wanted to as cosine of x plus x, right? Which would be, if we were to look back at this, would be cosine x sine x sine x. So this double angle identity comes out to be cosine squared x minus sine squared x. Now it looks very very close to cosine squared plus sine squared, which equals 1, but it's not quite. We got that minus in between. Okay, and this last one, cosine of pi over 2 minus x. Well, I want to illustrate this one using a right triangle. And this right here is a 90-degree angle, which is pi over 2. Let's say this angle here is x. Well, let's say that the cosine... well, let's go like this. Let's go, let's say we've got A, we've got B, and we've got C, right? So this angle right here would actually be pi over 2 minus x, right? These two angles, this angle and this angle right here, need to add to pi over 2 if that's a right triangle. Therefore, the cosine of pi over 2 minus x would be b over c. Right, so the cosine of pi over 2 minus x would be b over c. What that's equal to is actually equal to the sine of x, which is also b over c. Therefore, this is the sine of x. Alright, let's move on. Alright, sines. I'm not going to prove this in this slide, but the sine of x minus y is going to be the sine of x cosine of y minus the sine of y cosine of x. Okay, just how we did in the last slides. Cosine was even, but sine is odd. Therefore, it's symmetric about the x-axis. So it's symmetric. It's symmetric about the origin, right? So then there's a rotational symmetry there. All right. Sine of x plus y is going to be the same as sine of x minus y, except it's going to have a plus in between. So sine of x cosine of y plus sine of y cosine of x. So in sines, the sign is the same. In cosines, the signs are contradictory or the opposite. Alright, double angle for sine would be sine of x plus x. if you wanted to write it in a different form, sine of x plus x. Alright, so I would have had sine of x cosine of y, and, excuse me, sine of x cosine of x, sine of x cosine of x, which is 2 sine of x's cosine of x's. And it's double sine double angle identity, and as you can probably predict, the sine of pi over 2 minus x is going to be the cosine of x. Just some shortcut identities there available to you. Alright, here's the type of problem you might see in your homework. Example, given cosine is 1/3. When it's in quadrant, what would this quadrant be? Quadrant 4. And the cosine of a different angle, phi, is negative 3/4 when it's in quadrant 2. Let's graph them and then find some stuff here. Alright, so up here I've sketched both scenarios on the coordinate plane, one in the 4th quadrant, the other one in the 2nd quadrant. Alright, so we're going to go ahead and find, let's just do a couple of these. Let's find the sine of theta plus phi. Some call it phi. Alright, so that would be the sine of the first angle. So let me write this above. So that would be the sine of theta times the cosine of phi plus the sine of phi times the cosine of theta. Alright, so what would those values be? Well, sine of theta is root 8 over 3. I used Pythagorean theorem to find that root 8. Cosine of phi we already knew was negative 3/4. Sine of phi is root 7 over 4. Oops, red now. Root 7 over 4. Cosine of theta, 1/3. We already knew that. Alright, so the nice thing about all these problems like this is that you'll get a common denominator. So I'm going to have negative 3 root 8 over 12 plus root 7 over 12. And I can't do anything with combining terms due to the fact that those radicals are different. I mean, I could reduce root 8 to 2 root 2, but I might as well. Let's make it a varsity answer. That'd be negative 3 times 2 root 2. So what we'd have is negative 6 root 2 plus root 7 all over 12. That would be the sine of theta plus phi. Alright, let's try sine of 2 theta, or 2 phi. And we haven't talked about this yet, so we're not going to do that one quite yet. So let's do part C. Bring it down here. So sine of 2 theta, or 2 phi. Sine, oops, I should do that in red. Sine of 2 phi would equal 2 sine of phi cosine of phi. Alright, so sine of phi is, let's say here, we got 2 times sine of phi, which is root 7 over 4. Cosine of phi is negative 3 over 4. So to me, I'm seeing negative 6 root 7 over 16. Could reduce that. How about negative 3 root 7 over 8? That would be sine of 2 phi. If we doubled that angle, that's the sine value there. Alright, let's keep going. Alright, so proving some identities. when you do problems like this, you want to pick, first of all, you want to pick the more complicated side and work to the simpler side. And you can only work on one side at a time. Typically, the simpler side is going to be harder to expand and make look like the more difficult side. So I would always work with the more difficult side. So I'm going to work with the right side. And I'm going to try to make it look like cosecant plus secant. This 5 minutes, totally inaccurate. Maybe it means 0.5 minutes. I don't know. Maybe there's a missing piece there. But I would split this up into cosine theta over sine theta cosine theta plus sine theta over sine theta cosine theta. Alright, and what you'll get is some cancellation. So up here I'll get a 1. Up here I'll get a 1. And 1 over sine theta is cosecant theta. And 1 over cosine is secant theta. I've now shown that the right hand side is equal to the left hand side. And I can go ahead and put my signature on there. Sweet. Alright, compound angle identities. We're just going to show the formula and we'll prove it later, okay? So cosine of A plus B will be cosine A, cosine B. Notice the order of this, minus, plus. Okay? So if I have this plus, I have a minus. If I have this minus, I have a plus. Alright, and then I have sine of A, sine of B. Okay, that should be a review. Same thing for this, sine of A, cosine of B. Sines will stay the same this time, as whichever one is present. And sine of B, cosine of A. Alright, tangent is where it gets a little bit interesting. I want to prove it here actually. So tan of A plus B, I think we could argue is the same as sine of A plus B over cosine of A plus B. I'm going to expand that real quick and come back and look at it. Okay, so I expanded the top, I expanded the bottom, and I left some space here. And what I'm going to do is I'm going to divide each of these 4 terms by something, okay? And that something, whoever the person was that came up with this was probably from Arizona, because they said, hey, you know what, I'm just going to divide everything by cosine of A, cosine of B. I'm like, yeah, I'll just do that. I'm from Arizona. I like the Southwest. Let's go with it. So they did. Alright, and what happened was they developed a simple formula, or a simpler formula, for this tangent A plus B. Alright, we'll work with the sign change later. I'm only working with tan of A plus B, but we'll translate it in a moment. So let's cancel some stuff. Well, here it looks like cosine of B cancels. Here it looks like cosine of A cancels. Here it looks like everything cancels. So I become a 1. And over here, it looks like I get no cancellation. Now notice this. This reduces to what? That reduces to tan A. Oh, bad color choice. Let's go, I guess we'll go black. Tan A plus, what does this turn into? Tan B. What is the bottom left? Well, we turned it into a 1. And what do we have here? Tan A, tan B. Oops, that's supposed to be a T. Tan B. Alright, cool. We're going to develop one more here on the next slide. Okay, so double angle identities. We know this. Cosine of 2 alpha. We talked about this earlier. Is cosine squared A minus cosine squared b. This actually has, oops, I'm sorry, that should be sine squared. Sine squared a. Okay, it actually has two alternate forms. Those two alternate forms are 2 cosine, wow, squared a minus 1. And the other form is 1 minus 2 sine squared a. Okay, all three of those are alternate forms of cosine 2 alpha. Sine 2 alpha just has one form, 2 sine alpha cosine alpha. And tan 2 alpha is the same as tan alpha plus alpha. So if we were to write that out, that'd be tan a plus tan a. This is what we just did on the last slide, over 1 minus tan a times tan a. So what would that equate to? Well, it would be 2 tan a over 1 minus tan squared a. Alright, so here are your 3 double angle identities. And I believe, folks, that's it for today. That'll be some compound identities and others. Peace out. See you in Trig Day 4.